Well, we have some things to talk about. And what I'm going to do here in the plant, I don't know what happened. The other camera didn't work, but this one will. I'm going to make you a little seasick here for a minute. We're going to take you on a little ride. Get down here so you can see what we're doing. I have the power supply that we built. And one of the things that I did purposely, I left out a part. And I left it out purposely. I didn't say anything about it. It wasn't a contest. It was just to see how many guys were paying attention. And there were some of you, and thank you. You get the award. What was that part? This, a fuse. And in the whole design of the thing, if you remember, we had, I'm going to watch it because this is plugged in. We have 110 volts and 110 volts. But then here is the switch to turn it on. And the spare terminal is to wire in the fuse. My idea is to use a fuse that's that has leads on it. But there's all kinds of ways to do the fuse. You can do it in line or what have you. But during this whole project, everybody, use your own discretion, your own idea, make things happen. See, that's the fun of homebrewing. We don't have to stick to the plan because there really isn't a plan. Yeah, we show you what to do in the schematics, but get in there, do it. And I also have to tell you, I was so thrilled to get some comments on the wonderful, I should, you know, Ham Nation, we should patent this and the chipstick. But wait a minute. There's something extra. What is that? Well, that came from KA7 TPH. And it's a great idea because he was saying that he used these in his work years ago. And it's really tough on the capacitors just to short them out. You saw how that worked last week. We're going to do it here in a minute again. But if you put, and it isn't any big deal. This is I had a 220 ohm resistor that works fine, but I put a lead on it. So what we're going to do here, turn that little booger on. Gosh, you didn't get to see the light. See? That's purple, by the way. But watch what's happening here with the meter. She's coming right on over to 200 volts. Now, we're going to turn it off. What's going to happen? Wait a minute. I'll even unplug it. It's unplugged from the wall. Wait a minute. What's happening here? What's happening is these capacitors have stored that charge up. I tell you before, I told you many times, and I will repeat it each time. I got a couple of nasty notes from guys. Oh, my God, you're going to kill somebody. No. That's the warning. That's the warning. Come on. We're growing up guys and girls, and we're building things, and you're playing with some voltage. What are we going to do with that? Chip came up with a great idea. We're going to couple this to the ground lug over here, and I'm going to go over here and touch the capacitor. Watch what happens to the meter. It slowly goes down. That's because the resistor. And it's not hard on the capacitors at all. Okay. We'll turn it back on. And I have the meter on the output of it. And here she comes. It's charging the capacitors. That's why it does just come right on, because it's charging those caps. I'm going to turn it back off. It didn't go down, but it will when I touch the other end, the positive end of the capacitor. Down it goes. You be sure with any kind of, I even do this to my 12-volt supplies. Don't let the capacitors hold a charge. Take them down. I always used just a clip and a couple of resistors, but Chip came up with this great idea. Thank you, Chip. K9MIT. Thank him. He's on the chat room in there all the time. And what a great idea he had. But now we have a little addition. So there you go. There's nothing but a piece of wire, a resistor onto the clip lead. So again, it's just a safety part of things. Because I'm going to do something else for you. You see, all capacitors have the charge situation. That's what they're there for. But now I'm going to do something rather interesting for you. I have a 9-volt battery. And I have an electrolytic. And we're going to match up the minus to the minus. And we're going to put that little baby right across that 9 volts. Get in there. Okay? Going to switch the meter back down to 10 volts. And we're going to put that booger on there and watch what happens. Okay, there's 9 volts. So we saw it. Now here comes the cap. There's the minus. Wait a minute. The battery's here. Where's that coming from? Told you. We've charged it. And you can't just go away and leave these things. So we're going to take our old chipstick and we're going to make it go away. But you see, it'll go away a lot faster because we only had 9 volts. There again, you have to maintain safety. And that's what we're trying to do here. And the other thing that we're working on, and in the coming weeks, we'll have all the other parts and stuff, but we've got, and a lot of you mentioned it, and I appreciate any comment, good or bad. I want to hear it because we're all learning, of course. We're going to come out of that power supply at where we took the chipstick and died, and we're going to build us a bleeder setup. These are resistors. And because of that, we can have different voltages. This, of course, is ground. And we'll be getting into the size of resistors and so on. One of the reasons I don't know yet is I have to get all of the other parts together. That's why, if you remember, there are extra terminals on this screw strip on the output. That's where we'll mount the bleeder resistors. And these guys will allow us to bleed that down, and we won't have to worry too much about the old chipstick, because that'll be bleeding that plus voltage down. But we need to have different voltages. We'll be able to do that, and that's how you do it. All your transmitters and receivers, they have power supplies just like this. They'll come out of the rectifiers. Bingo, way you go. And the other thing that we're going to work on is I'm going to work on the filter, because depends on how it all comes out. We're going to work on that B plus a little bit. You see, what we have now coming out of that, just the capacitors, the rectifier and the capacitors, what we have there is a situation that it's 200 and some volts, true. But guess what? It looks like this. Well, we don't want that. We want to filter that better. You can just count 60 cycles, 120 cycles, whatever. How do we do that? We do that with filter networks, a big choke or more caps, and we'll figure that all. But what we're going to do is we're going to cut the tops off of those babies so that we don't have that ripple effect. That's what we do with power supplies. We have filter networks and all kinds of other things that make sure the voltage is not going to hum and buzz and crackle We'll get into more of that as we go. I'm working on the mic preamp now, and I'll keep bringing you some of these great things that we're doing, and I want you all to follow along. But no matter what happens, all through this project and any project you do, you want to make sure that safety first. That's so important. And I have the camera over here. I've had a lot of guys ask me again, showed it last week, but here it is again, where the parts came from and what we need to do for the power supply. There you are. This is the basic power supply. There will be other resistors and stuff, but this will get you going. Notice here, one fuse holder. Everybody missed that last week. I did it just because I could. And the vacuum tubes we're going to need, 6X5s, 12AU7. And those come from a really great company called vacuumtubes.com. They really have great tubes at a really good price. Antique Electronics is going to be your main supplier. They have everything. You go to that site, I guarantee you will spend sometimes hours. Man, they have everything. So for all you guys that say, oh, you can't do that high because you can't get the parts. Oh, yes, you can. And they really have a great catalog of antique electronics. Well, to us, it's antique for some, but not for us. It's everyday stuff. And then remember the ceramic tube. That tube socket's great. I love that tube socket. So do you, don't you, George? That is a must. And those come from esrcvacuumtubes.com. I guess you could get your vacuum tubes there too. He has a lot of things also. So there's a great list of parts and the suppliers. So no excuse. And there's the diagram again. We'll continue to go through some of it. One thing I'm going to point here in the last. When you're looking at antique electronics, if you really want to get into it, they have a kit. It's a power supply kit. And I would advise everybody that wants to get into building a little more, it's fine to build what we're doing here, but this son of a gun has voltages from, I think it's 150 volts all the way down to, I think, 3 volts. All the different taps. It's kind of hard to see on this little thing here, but these are all outputs for different voltages. There's, I think, 3 regulators in it. They're using solid state rectifiers. Check it out, K101A. Everybody needs a bench supply, and this baby is it. I really think you should take a look at that. And they have almost like the old Heath kit. Check this out, George. Is this cool? And guess what? It's built on pine board. You get a board. Do you know about this, George?
No, I don't. I have not seen this before.
Oh, man. Yeah, it's just really fabulous. And there again, antique electronics. There's a diagram for it. Give you a little better insight. And I think it's like $40. Oh,
really?
Yeah, 45. I think I'm right on that. It isn't very much money. My gosh, the transformer costs more than that in most cases. But I love it. There's all the voltages. I get that on the camera, right? 22, 45, 67, 90, and 135. And then there's also 1.2 to 6 volts. So what a great thing. So there you go. Antique Electronics, man, they're your people. I mean, they've got some wonderful things going on.